What's up guys? Welcome back to my YouTube channel, and for this vid, I will be doing the chapter 8 and the activities in chapter 8. So if you want to learn something from here, if you want to get some informations about the chapter 8, stay tuned, and please watch, and I'll be back guys. Okay guys, again, welcome back to my YouTube channel. And as I said earlier to my intro, that I will be doing the chapter 8, the activities in chapter 8. So for our first activity in chapter 8, we will be calculating the subnet mask, or the basic activity of the chapter 8. So the title is Calculate the Subnet Mask, or open close parenthesis basic. So the instructions is, in this activity, you are given a subnet mask in decimal format. So enter the binary representation of the subnet mask in the octet fields provided, and additionally convert the mask prefix notation format in the prefix notation field. So as you can see there, tables, the calculate subnet mask. So they are given the subnet mask is the 255, then again 255, then 255, then 254. So we will be putting the subnet mask in binary and the prefix notation. So how we can get the subnet mask in binary? So in our decimal conversion in chapter 7, as you can remember, the base is the 2, then there is 1, then 2, 4, 8, then 16, 32, 64, and 128. So the total of all that 8 numbers is 255. So if the subnet mask is 255, so we will be putting here in subnet mask in binary. So we will be putting there all number 1, because 128 plus 64 plus 32, then 16 plus 8 and plus 4 plus 2 plus 1 is equals to 255, and our subnet mask is 255. So we will be putting all number 1 and 8, number 1, 8, and the same as the next, the 255 also is number 1, then also 255 and number 1. Then in our next given subnet mask is 254. So the we will be adding some binary, or in the base, to get the 254. So 128, so I have my calculator here. So 128 plus 64, then plus 32, plus 16, then plus 8, then plus 4 is equals to 252. But the given here in our subnet mask is 254. So 252, so plus 2 is equals to 254. So there are 7 number, the 7 numbers. So we'll be putting a 7 number 1, 1, 2, 3, 4, 5, 6, 7, and number 1 in our base position is not added to the numbers to provide the 254. So we will be putting it 0. So for our next here in prefix notation, to get the prefix notation, we will be counting all of the number 1 in the subnet mask in binary. So let's count all the number 1 in subnet mask in binary. So 1, 2, 3, 4, 5, 6, 7, 8, then 9, 10, 11, 12, 13, 14, 15, 16, then 17, 18, 19, 20, 21, 22, 23, 24, 25, and 6 and 7, 28, 29, 30, 31. So 31. But to put the prefix notation, we will be putting slash, then the number. Again, our prefix citation is 1, 2, 3, 4, 5, 6, 8, 16, 17, 18, 19, 20, 24, 25, 26, 27, 28, 29, 30, 31. So we will be putting number 31. So let's see if it is correct. And it's correct. So you have correctly converted the subnet mask to binary and prefix citation formats. So if you want to try again, so click the new number. But that is how on how we get the subnet mask in binary and the prefix citation. Okay guys, for our next activity, our activity is entitled determine the number of bits to borrow. So the instruction is, in this activity you are given the number of hosts that are needed. So determine the subnet mask that would support the number of hosts as specified. So enter your answers in binary, decimal, and prefix citation format in the fields provided. So in this activity, there are hosts given, the number of those. So the number of the hosts or the hosts needed is the 250, the 25, the thousands or the 1000s, then the 75, the 10, and the 500. So we will be specifying, or we'll be putting our answers in the subnet mask or the binary, then the subnet mask, decimal, and the last is the prefix citation or the right. So in our 25, the subnet mask of our 25 is 8 number 1. The next is also 8 number 1. Then the next one is also 8 number 1. But in our fourth box, there are only 3 number 1, then the rest is 0. Then next one, in our thousands, there also a 8 number 1. Then the next box is also an 8 number 1. Then the next one, in our third box, there is 6 number 1, 1, 2, 3, 4, 5, 6. Then the rest is 0. Okay. And in the our last box in thousands, we will be putting all of it 0. So here in our 75, also we're putting number 1. Also in the second box, number 1. And also in the third box, 1, 2, 3, 4, 5, 6, 7, 8. And in our fourth box, there are only number 1, and the rest is 0. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so for our 10, for our 10 is, we will be putting here number 1, also number 1, 8 number 1. Then in the next box, also 8 number 1, 1, 2, 3, 4, 5, 6, 7, 8. And in the third box, we will be putting also 8 number 1. Excuse me. But in our fourth box, we'll be putting a 4 number 1. So 1, 2, 3, 4, and the rest is 0, 1, 2, 3, 4. So in our 500, in our last host, so 500, we'll be putting here a 8 number 1. Then the next box is also a number 1. Then the third box is, we'll be putting it a 7 number 1. 1, 2, 3, 4, 5, 6, 7, and 0. And in last box, in 500, we'll be putting it 0. So here in our subnet mask decimal, for our 25, we will be putting a 255.255. 255.224. Our next is 255.255 also, then 252.0. So for our 75, 255.255, then 255, then 0.128. Okay. So in our next, in our 10, so 255.255, 0.255.24t. Then for our last, the 500, we'll be putting 255.255 0.254.0. So for our prefix notation, in our 25, or our the prefix notation in 25 is, we'll be putting a slash, then number 24. No, 27. So in our next box, in the thousands, I will be putting slash, the number 22, and in our 75, slash, then 25, then in the 10th, slash 28, 25, then slash 28, and for our last 500 will be slash 23. So let's see if our answers is correct. And it's correct. So you have correctly determined the subnet mask and entered it in binary, decimal, and prefix notations. Okay guys, so for our last activity, the part 1 is practicing VLSM. So the instruction is table 1 uses regular subnetting to accommodate the network shown. So table 2 uses VLSM to further subnet the network. So drag the addresses to the appropriate subnet description. So calculate 50 users per subnet. So our first is the new subnet mask, or the decimal. So it is the 255.255.255.192. So the next one is the first prefix notation, or it is the notation number 26. So the first full subnet range, it is the 192.168, then 5.0, then 192. So for our second full subnet range, it is the 192.168, then 0.5.64, and for our last full subnet range, it's the 192.168.5.192, and so on. So let's see if it's correct, and you have correctly calculated the subnet. So for our figure 2, or the activity part 2, again the instruction is table 2 uses VLSM to further subnet the network. So drag the addresses to the appropriate subnet description. So use table 1's second full subnet range and VLSM to calculate for 20 users per subnet. So okay, our second full subnet range, notation 26 from table 1 is the 192.168.5.64. Then the next one is the new VLSM subnet mask decimal. It is the 255.255.255.224. Then the VLSM prefix notation is the notation number 27. Then the first full VLSM subnet range, it is the 192.168, then 5.64, and the last one is the last full VLSM subnet range. It is the 192.168.5.96. So let's see if it's correct. And it's correct. So you have correctly calculated the subnet using VLSM. So that's all for this vid, guys. Thank you for watching, and I hope you learned something from me, or you got some information about the chapter 8. And If you want to subscribe in my YouTube channel, please click the subscription button. And if you want to notifications about my new videos, so please please hit the subscription bell. So in my next video, I will be doing the activities in chapter 9. Thanks, guys.